Good morning friends. Today we are going to see the next point from the topic oscillation, that is equation for acceleration, velocity and displacement of a system using differential equation. Friends, this is a very important point from this topic. In this part we are going to see the equation for acceleration, velocity and displacement, and these equations are very useful in order to study the topic oscillation, as well as these formulas are very useful regarding the CET, JEE and the NEET point of view. So many numericals will be created from this point. Friends, before we begin this equation, we have studied the equation of the differential equation in the last period. So first we have to recall that equation. So what is the differential equation? d2x upon dt square plus omega square x is equal to 0. So this is a differential equation. Friends, using this differential equation, we have to derive the equation for acceleration, velocity and displacement. I am going to divide this equation into three parts. There is a total mathematical part. So in this part, there is no theoretical part for the explanation. Just we are going to solve just like as a math. So here I am going to divide the equation into three parts. First I am going to derive the equation for acceleration in part first, part 2 for velocity and part 3 for the displacement. So here I am going to write part first. Part first, the equation for acceleration. As we are using symbol A for the acceleration, so this is I am going to use the short form of the acceleration. Okay, the differential equation is d2x upon dt square plus omega square x is equal to 0. So this omega square will be go on this side, then it becomes d2x upon dt square is equal to minus omega square x, and d2x is second derivative of displacement, and the second derivative of displacement is nothing but the acceleration. So you can write here acceleration is equal to minus omega square x. So this is our part first. The negative sign indicates that the acceleration and displacement both are directed in the opposite direction. So here we have completed the part first, the equation for the acceleration. Again I am going to explain this part. The differential equation for linear system is d2x upon dt square plus omega square x is equal to 0. d2x upon dt square is equal to minus omega square into x, and d2x upon dt square is nothing but the acceleration. Now next part is part 2. We are going to derive the equation for velocity. Part 2, the equation for velocity. Friends, in your textbook the equations are written directly. I am writing this heading so that we can get a clear idea where the first equation will complete and where the second equation will start. Now acceleration. So the equation for velocity will depend upon the acceleration. So we should begin from this. Acceleration is equal to minus omega square into x. But what is acceleration? Acceleration is nothing but the rate of change of velocity. So we can write here dv by dt is equal to minus omega square into x. After this, the step which I am going to write, that is very important. Here, divide dv with the dx and multiply with the dx. So that rearrangement dv upon dx multiply by dx upon dt is equal to minus omega square into x. Now dx upon dt, displacement upon time, is nothing but the velocity. So we can write here dv by dx is equal to multiply by v is equal to minus omega square into x. Now take this x on this side, it becomes v into dv is equals to minus omega square to x. After this we have to take the integration. Taking integration on both sides. So integration of v into dv is equal to integration of minus omega square x into dx. According to the rule of integration, when we are taking the integration, okay, so taking integration on both the sides, integration of v into dv is equal to integration of minus omega square x into dx. So when taking the integration, remember what is here, power of v is 1. So we should add 1. So 1 plus 1, 2. So v square by 2 will be the integration of v into dv. Here integration of omega square is a constant. So integration of x is a x square by 2. So I am going to write here that integration of v into dv is equal to minus omega square integration of x into dx. X into dx. Okay, so it will become v square by 2 is equal to minus omega square x square by 2 plus c, where c is a constant. Where c is equal to constant. Now we have to find the value of constant c. In maths you have seen it in the integration part, how to find the value of constant. In order to find the value of constant, we should put v is equal to 0 and x is equal to a. What is a? A is maximum displacement, that is an amplitude. So the equation will become 0. So this is will be my equation number 1. So 0 is equal to minus omega square a square by 2 plus c. So this minus will become plus. So omega square a square by 2 is equal to c. Equation number 2. Put the value of equation 2 in 1. We have to substitute the value of equation 2 in equation number 1. So what is the value of in equation 2? That is the value of c. So omega square a square by 2. This value we have to put in equation number 1. So it will become v square upon 2 is equal to minus omega square x square by 2 plus omega square a square by 2. Now 2 will be cancelled from the denominator. So we are getting v square is equal to minus omega square x square plus omega square a square. Now v square is equal to omega square, take omega square as a common, take positive sign, a square minus x square, and after taking the square root we are getting v is equal to plus minus omega under root a square minus x square. So this is the equation for velocity of the particle performing a jump. So we have completed the part 2. Again I am going to explain this part. Part 2, the equation for velocity. So the equation will begin from the acceleration. What is the equation for acceleration? Minus omega square into x. So acceleration is equal to minus omega square into x. What is acceleration? The rate of change of velocity. So dv upon dt is equal to minus omega square into x. Now this step is very important. So I have written the star marks here. Divide the velocity with the dx and multiply with the dx. So dv upon dx multiply by dx upon dt is equal to minus omega square into x. Now dx upon dt, displacement upon time, is equal to velocity. So v dv upon dx is equal to minus omega square into x. Now do the cross multiplication. So v into dv is equal to minus omega square x into dx. Then we have to taking integration on both sides. We are taking the integration. So integration of v into dv is equal to minus omega square x into dx. Now by taking the integration, the rule is that we should take the constant out of the integration. So omega is a constant. So in the next step we have written v into dv minus omega square integration of x into dx. So as we are taking the integration, so what is integration of v into dv? V square by 2. What is integration of x into dx? X square by 2 plus c. C is a constant. And in order to find the value of constant, what we have to do? put v is equals to 0 and x is equals to a. So if we substitute this, we are getting the value of c as a omega square a square by 2. So put the value of equation 2 in equation number 1. So it will become v square by 2 is equals to minus omega square x square by 2. In the place of c, we have written plus omega square a square by 2. Now 2 will be get cancelled. So v square is equals to minus omega square x square plus omega square a square. Now v square is equals to take omega square with common into bracket a square minus x square. So v is equals to plus minus omega under root a square minus x square. This will indicate the equation for velocity. Now we are going to see the part third. The equation for displacement. And displacement is going to be symbol x. In order to find the equation for the displacement, we have to use the equation for velocity. What is velocity? Velocity is nothing but the rate of change of displacement. So v is equals to dx by dt. What is the value of v? So we have the value omega under root a square minus x square is equal to dx upon dt. So plus minus is there. We have not taken the sign. We are taking only the positive sign here. Now we have so v is equals to dx by dt. And what is the value of velocity? Omega under root a square minus x square. Now omega into dt back one side and dx upon under root a square minus x square. After this, we have to write that taking integration. So integration of omega into dt is equal to integration of dx upon under root a square minus x square. So in the mathematics, we have studied the formula integration of 1 upon under root a square minus x square. Now the value sin inverse x by a. So here we are going to write the omega t plus phi. So integration of dt is a t plus phi we should take the constant is equals to sin inverse x by a. So this is the mathematical formula of integration. Integration of 1 upon a square minus x square. 1 upon under root a square minus x square have the value x by a. So that we have to take. So take the sign on this side. So it will become sin omega t plus phi is equal to x by a. Therefore, x is equal to a sin omega t plus phi. So this is the equation for displacement. So friend, I am going to explain this part third, the equation for displacement once again. So the equation will begin with the definition of velocity. So what is the velocity? The rate of change of displacement is known as the velocity. So v is equals to dx by dt. What is the value of velocity? Plus minus omega under a square minus x square. So remove the sign. So take the only binomial part. So omega under a square minus x square is equals to dx by dt. So take omega into dt is equals to dx upon under root a square minus x square. Taking integration on both sides. When we are taking the integration, so integration of omega into dt with the value omega t plus phi, and integration of dx upon under root a square minus x square have the value sin inverse x upon a. So this sin inverse, when we go on the LHS side, it will become sin. So sin omega t plus phi is equals to x upon a. Therefore, x is equals to a sin omega t plus phi. So friend, today here we have seen the three equations. The equation for acceleration, equation for velocity, and equation for displacement. What is the equation for acceleration? Minus omega square into x. What is the equation for velocity? Plus minus omega under a square minus x square. And what is the equation for displacement? X is equal to a sin omega t plus phi. So using the differential equation, obtain the equation for displacement, velocity, and acceleration. Such kind of equation will be asked in the board examination for 4 marks. This is a very important part. Friends, this is a total mathematical part, and once you will understood how to write the equation, then you will never forget. And here there is no theoretical part, so you can get the out of out mark in the board examination for such kind of the questions. Friends, we are going to see the next point from this topic, which is based on this equation. Next point on this topic is the equation for displacement, velocity and acceleration of particle at mean and extreme position. So equation for displacement, velocity and acceleration of the particle at mean and extreme position. So what is mean position and what is extreme position? So suppose I have one simple pendulum. So this will be initially at point A. So this point is known as the mean point. Now this pendulum will be got displaced and it will move to point here B, or it will move to point C. So these are known as the extreme points. Extreme. So extreme. So there are the two extremes. When it will be on the positive side, or when it is on the right side, we can take the plus and plus A. And when it is a negative side, then or when it is on the left side, we can take as a minus A. Suppose it will be here, then we can take the plus A amplitude, and if it will be moving on the LHS, then we can take as a minus A. So friends, there is only one mean position and two extreme position. Okay, now we'll see one by one. First for the displacement. Here also I am going to divide the answer into three parts. Part first. X is equal to A sin omega t plus phi. Okay, so this is the equation for displacement of the particle. Now here we have to consider the two cases, for mean position and for extreme position. For mean position, when we are saying about the mean position, for the mean position x is equal to 0, because particle will be here, and as the particle is at the mean position, then it is not moving, the displacement of the particle will be 0. For extreme position, we have to consider omega t plus phi is equal to pi by 2. So this value you have to put. So x is equal to A sin pi by 2. So this is for the displacement of the particle. So what we can say, for when we are obtaining equation for the displacement of the particle at the mean position, then it will be considered as a 0, and for the extreme position, it will be considered as a x is equal to A sin pi by 2. Now next we will go for the acceleration, part 2. What is the equation for acceleration? Acceleration is equal to minus omega square root x. Right, this is the equation for acceleration. Now here also we have to consider the two cases for mean position. Okay, for mean position, what we have to put? X is equal to 0. So what is the value of acceleration? Acceleration is equal to minus omega square root 0. So acceleration will be 0. For extreme position, what we have to do? Put x is equal to A. So acceleration is equal to minus omega square into A. So what we can conclude from this equation? We can say that the acceleration of the particle is minimum at mean position and maximum at extreme position. So this is the equation for acceleration about its mean position and at extreme position. Now part 3, for velocity, right? What is the equation for velocity? V is equal to plus minus omega under root k square minus x square. So this is part 3 for velocity. Here also we have to consider the two cases for mean position. So for mean position, x is equal to 0. When we are substituting x is equal to 0, then v is equal to plus minus omega under root a square minus 0, and square root of a square is equal to a. So v is equal to plus minus a omega. This is the equation for velocity at its mean position. For extreme position, what we have to do for extreme position? Simply substitute x is equal to a. So if we are substituting x is equal to a, so what will happen? A square minus a square, it will become 0. So I am going to write here directly b is equal to 0. So what we can conclude? We can conclude that the velocity of the particle performing SHM is minimum at extreme position and maximum for the mean position. For the CET, JEE and NEET type of the examination, the questions may be asked regarding the extreme and mean position. Friends, today we have seen a very important part on the topic of oscillation, that is using the differential equation, obtain the equation for acceleration, velocity and displacement of the particle. And second part which we have seen, the equation for displacement, velocity and acceleration of the particle about its mean position and extreme position. These are very important points from this topic and regarding the board examination also. Friends, make the notes properly, and if you have any kind of doubt, then you can ask when you will come to the college for exchanging the books. I hope you have understood this point. Thank you. Have a nice day.